Okay. I think you all can hear me. So I'm going to give the lecture in at 12:30. Still have 5 minutes. So in this lecture, last Friday, we have discussed about the structure definition and we cover about the dynamic memory allocation, the malloc and the free function, how to use them, and why you need to use it so that you can let the user to create to dynamic allocate the memory to create some array uh, during the execution time. Previously, what you have learned is the static data structure, which you have to decide the memory size at the compile time. So when you have the dynamic memory allocation using the malloc and free, you have more flexibility to allocate to use your memory and let the user decide the array size, the memory, how to use, and you can allocate, you also can deallocate. That's what you have learned it on Friday. In the end of the lecture on Friday, I also cover a bit the cell referential structure. That is the basic element to create a linked list. So yeah, that is what roughly what you have learned in the last week Friday lecture. That is a very important concept you need to know because today we will cover about the linked list and it's based on that you can create you can dynamically allocate the memory. And then next stage is like I'm not only want to let the user to create a arbitrary size of the array. I also would like to let the user to insert the new nodes, insert the data into a data structure, and also allow the user very easily to remove the data from the data structure, which is linked list. Because what you have another weakness of the array is if you want to you can easily insert the data into an array, but you want to remove a data from an array is not that easy. Or I would say actually when you're trying to insert, actually you already declare a fixed size. So you want to increase, you want to insert more data is not easy. You want to remove some data from an array is also not an easy job to do. So linked list can overcome it. Of course, linked list have other weakness which we will discuss in the end of the lecture today. And yeah, we will discuss today. Then tutorial and the lab will be start from next week. I will upload the material in these 2 days. As I'll try to do it as soon as possible. And yeah, that will cover about this linked list. And this week still the add drop period. By end of this week or this Sunday probably, I will trying to release the assignment one to you soon. Yeah. Still have 1 more minute. What about today is Tuesday. Yes, we may affected in that week. So you in the if you look at the our blackboard, you can see that we do not have any tutorial and lab in week 4 due to the Chinese New Year. Lecture wise, I think I will probably do a video recording before the Chinese New Year, so you can watch it. It will only affect the Tuesday section. Friday is not the public holiday, so we still will give the lecture on Friday. So for Tuesday one, I probably will record an additional video lecture for you to watch it. Okay. So today we will cover about this linked list, the linked list and its application and its implementation. So in today's lecture, I will tell you what is the linked list and how do we create a linked list and how do we use the linked list we create and why do we need to use the linked list and why not everything just use the array. What is the advantage and disadvantage of using a linked list instead of an array in the end of this lecture. So what is the linked list? I think in the last Friday lecture, we have mentioned about that you can use the malloc and free to dynamically allocate a memory block for an array or any variable you want to you declare earlier, so that you can let the user have that freedom to create, allocate and deallocate the memory block for that particular variable. It may not be an array, it can be any variable. Just normally we don't have to do so because you can just simply declare a static data structure for a variable. So, but the good thing having the malloc and free is you allow the user to deallocate, to remove the variable when you no longer need to use it. That can help you to save some memory when you have limited memory resource. Then but that may be not enough. You will find that a lot of time you face the problem is that you need to add more data. You also need to remove some data. You need to give the user this flexibility. For example, if we want to create an attendance list, right now is the add drop period. Some student may register this course. Maybe tomorrow some student may want to drop this module. So the database, we may need to add new student into the system. We also at the same time we need to remove some of the student who drop the module. So some problem we may face this kind of a situation that we need to insert or remove certain data during the execution time. So these are the things you cannot determine at the compile time. And simply use the malloc and free is not enough. Yeah, or very troublesome. That's mean every time if you don't have a new data structure, you just simply use the malloc and free. That's mean every time you need to remove all the data and recreate a new data and reinsert all the old data first and remove the particular data you no longer need it. So that may be not a good idea. So therefore, this is what you have learned in the last Friday. To declare a data structure, you list out all the member and group them into one new structure called, here we call it student. Then can be a string, can be an integer, can be anything. Then if we further introduce another member, which is a pointer member, that point to a structure of the same structure type. Yeah, like this one. This is as a link. So this particular member is a pointer which have the same structure type as this structure you declare. So this is known as a cell referential structure. And this particular structure, you can think as a nodes. Yeah. So as a nodes containing the name and the metric number. And at the same time, there's a pointer. And this pointer is the link. Is a link which can bring you, which contain the memory location of the next nodes. Yeah. So this is the basic element of linked list, which is a cell referential structure. It contains all the data you need, name, metric number, anything, and plus one link, the memory location, a pointer to store the memory location of the next nodes. So this particular structure can let you just need to repeatedly create these particular nodes. You can endlessly insert the new data. So the next data, like Anna 2, Peter 3, James 4, and so on and so forth, we can keep adding. You can easily create this particular structure and include the new data into this list. This list, since they are linked to each other, then we call this as a linked list. And the last nodes of this particular data structure, we will usually put a null pointer. That means we just simply there's no, it contains zero memory location to indicate that this is the last nodes. There's no more next. There's no more link to the next node. There's no more nodes at the back. So to indicate that you can stop your searching, your travel, your print, and so on and so forth. This is the last nodes. So we use the null pointer to indicate the end of a linked list. So having this, we can easily create a very long linked list. In theoretically, depend on your memory. Theoretically, you can infinitely insert the new nodes at the back of the nodes, of the current nodes. Yeah. So in this, each nodes contain the data and a link. And the link, this pointer contain the address of the next nodes. So in other words, you just need to give me the memory address of the first nodes. For example, in this case, John 1 is the first nodes. So you just need to tell me the memory address of the first nodes. I can print out, I can find all the subsequent nodes of this linked list. Because the first nodes contain the memory address of the second nodes in the link, in its link. Then the third node's memory address is stored in the link of the second nodes. The fourth nodes, the memory address of the fourth nodes is stored in the link of the third nodes, and so on and so forth. And the last nodes, the link of the last nodes is a null pointer, which in other words, this is the last node, so there's no more next nodes. So you will just simply store a null pointer to its link. So that is a very basic data structure of a linked list. And since you only have, of course you can have, later I will show you some other kind of linked list which can have more than one pointer. In this particular basic linked list, they only contain one link. So one link, one pointer, which is a singly linked list, which we know it as a singly linked list. That means you only can move in one direction. So in this kind of a data structure, the memory address of the first nodes is very important. If you lost this memory address, you will not be able to find this linked list, any nodes in this linked list in the memory, or very difficult to find it if you lost the first nodes, because only the first nodes know where is the second nodes. Only the second nodes know that where is the third nodes. And moreover, the third nodes won't be able to know where is the second nodes. In this particular singly linked list, only in one direction. It's one way. You only can access the current nodes from the previous nodes. Yeah, the current nodes will not be able to know where is the previous nodes. And there's only one link, there's only one node know the next nodes. So always the first nodes, the so-called, we call it head pointer, is the very important pointer. Normally we wouldn't go and modify that particular pointer. We can assign this pointer, we can duplicate the memory address of the head pointer to another pointer to let that pointer to help us to travel along this linked list. But we eventually we still need to have a variable, a pointer, to store the memory address of the first nodes. No, we will cover more advanced linked list later, other structure. But this is the very basic component to build a linked list. Of course, I can simply, later you will see that I can simply extend to declare more pointer to let me create a more complicated linked list later. Okay, so this is the basic definition of a linked list. And how do we create a linked list? How do we insert a linked list? Yeah, next step is, well, this is the definition of a linked list structure. So always you will put all the data as the member, and in the end it comes with a pointer which is have the same data structure type as the what you define at the beginning. And this is the link which contain the next memory location of the next nodes. And there are two ways. Of course, the dynamic one is more important. So basically, you will use the malloc to allocate a memory block for a node. Okay. So, and then you will assign the data, the value into each member. Maybe here there's a typo. I think I might. I have to correct it. I think I made a typo. This one should be item. So this is not the... Okay, make it simple. I should change it to data. Okay, so after you declare a node, you will assign the value to it. So here I just show you a very simple example. So I just create one node for a linked list. So I just simply put the data into this member, data member. And then the next node, at this moment, I have no idea what it is. So I just simply assign null pointer to it. Later, if I write a loop, you see every iteration, I maybe read the data from the user, get the data from the user, and then I will try to declare a new nodes by malloc in every iteration. Maybe I think next example will be clearer. So to access like I said, as I mentioned earlier, to access this linked list, yeah, I always need a head pointer. A pointer, maybe here I call it head pointer. Yeah, to store the very first memory address, the first of the first nodes, the memory address of the first nodes. This memory address is very important because only I just need to know this particular memory address. I will be able to, from that, I will find out all the component, all the nodes in this particular linked list. So I cannot lose this particular memory address. If I lost this particular memory address stored in the head pointer, I will lose everything in this linked list. I won't be able to, theoretically, I won't be able to find the every nodes in this linked list once I lost it. So that is something important. So that so if you're trying to free after what happened if after I free the dynamic nodes, the head pointer, this head pointer is still point to the same location. It's just in that particular, I think in the last Friday lecture I have shown you, you will find that the dynamic, this head pointer is still storing this particular memory address. But inside this, the content in this particular memory address, after you call the free function, the content, you may not know what it is. It can be depend on the computer system. Some computer system may just clear the memory. Some computer system maybe still keep the data, but a while maybe other when you run other program or in your program you're trying to call the malloc again to allocate another memory block for other purpose, and it may reuse this particular free memory location for other purpose. Then your head pointer may still point to the same location, so it may see different things from time to time after you free this particular memory block. So just always have to remember that after you free this particular memory location, you're not supposed to revisit this particular location again. Although you still know where is it, you still know the original location by this head pointer, but actually the data inside this location is no longer valid data. You already free it. You're not supposed to reuse it. That is a common some common mistake student may make. After you free, you're trying to revisit it, and in some computer system, you still be able to get back the same data. But in some computer system, you may not be able to get back the same data. So in that circumstance, you may find that your program is working in computer A, but it doesn't work in computer B. And for this static, is just for you to just show you an example. Actually, we can declare a static linked list, but normally we not doing that because that in other words, at the compound time, you need to hard code all the data manually. If I know I got how many data, normally I will just simply declare an array. So that's why here I'm not emphasize the static nodes. Theoretically, I can do so. And when I declare a static linked list, in that circumstance, I use the dot operator to access each member. But normally in practice, we use the dynamic nodes. We create all this is a dynamic data structure. In practice, we do that because it should be, we use the linked list is because at the compound time, we have no idea how many data we will insert into this particular linked list. So we won't be able to hard code it at the compound time because we only know the data at the execution time. And we would like to let the user to have the freedom, to have this flexibility to insert and remove the data. So that's why we use the linked list. If that is the case, dynamic nodes is more practical. In fact, I'm not really free the head pointer. We free this particular memory location. So you can free head or you can free dynamic nodes, but you only do it once. There's no point to do it 2 times. because only that particular, you just want to free that particular location. And the head and dynamic nodes, here is just a pointer. Store the memory address, point to that location. Just point to that location only. They just store the memory address. So when you set free this particular memory location, you just free that particular memory location. The pointer itself still store that memory location, that memory address. It's a bit like your home address. Head pointer store your home address. Then free function is just go to your house to clean everything. But your home address still store in the head pointer. And just like after I free it, you go back to your home, you find that everything is removed from your home. That's so you no point to free 2 times. You free 2 times, you still, it's still useless. Because you free the first time, you already clean all the memory there. You already deallocate that particular memory block for other purpose, for other people reuse it. So why do we need a head pointer? And here it just like I just want to, okay, you can use the dynamic nodes to store. Head maybe is just it's just let you to be able to travel, because I always need to use one variable, one pointer to remember the first address. And I will use another one. Maybe you can give whatever name you want to travel along this linked list. But eventually, I still need to keep the first one. If I lost the first one, I won't be able, I won't be able to visit this linked list second times. So to play safe, normally we will declare a pointer to store the head point, to store the first memory address. And normally we won't go and modify it. And then we will declare another variable, another pointer for us to update the memory address to travel along this particular linked list. And here, okay, maybe this is just an example. I just create one simple node. Maybe here I trying to, okay, this one may be a little bit better, which I trying to run a while loop. And in the every iteration, I trying to take some prompt the user to give me an integer, and then every iteration I will declare a new node, and I will insert this particular input into the nodes, and then I keep running. So that is typical way we create a linked list. And in this case, of course, at the beginning, I just simply declare the head pointer. At the beginning, always the first case is because the linked list is empty. So it's a null pointer at the beginning. So when we insert the new data into the very first nodes, we will declare malloc will be assigned to the head. And subsequent new nodes, I will malloc the new nodes and assign it to the 10 next. To declare. So you expect that is like what this thing trying to do. In this line, what I'm doing, I will declare a list nodes pointer. Actually at the beginning, just a list nodes pointer is a pointer. At the beginning it point to nothing. When I get the user input, the first input, so I will run this part. In that case, this one, I will declare a new, I will allocate a memory block by malloc. So malloc will help me to allocate a memory block, which can allow me to store an integer and a next nodes. So I can store a memory address, and then this is an integer, they allocate a memory location for me to store an integer and a pointer. And then I assign this memory address, let's say example, let's say this memory address, this memory block is at 1000, 0x1000 for example. In that, after this line 11, yeah, this particular head pointer at the beginning is point to the null pointer. After the line 11, you will store 0x1000. In that circumstance, you will, in other words, this head pointer will point to here. Then I will let the temp, I got another pointer which is called temp pointer. Temp also do the same thing, so the temp will point to the same location. That means I got another pointer called temp, which also point to the same location, 0x1000. Same location. So this head and temp are pointing to the same place at this moment. And at this moment, I have no idea what is temp. So temp item will be after line 18. After this, I will run this one. Then you will assign a value which the user given earlier. Let's set maybe 50. If I key in 50 at the beginning, then they will store 50 here. Then in the next iteration, after that, they will run to the next iteration. Then they will prompt the user to key in the new data. Let's say the user type in 40. Then at this point, head is no longer a null pointer. Then that means they will run this portion. So the temp is here. The temp next is here, is this one. So again, they're trying to, in the line 15, they will use a malloc to allocate another memory block. Let's say this memory block is at maybe 1040. For example, yeah, just some memory address for you to store an integer and a pointer. Then this particular memory address will be assigned to the temp next, which is this location, will store 1040. In other words, the temp next, this particular, or head next, this particular pointer is pointing to this memory location. So that I can keep running this particular while loop, and this particular while loop will use a malloc to create a new memory block. And this new memory block, the memory address of this new memory block will be assigned to the link. And keep doing this until the user key in some invalid number, or some invalid maybe alphabet or symbol. As long as you not key in any integer number here, they will return false. Then they will not carry on this nodes creation. Then the last, that means you are in the last nodes. So the last nodes, remember to declare it as a null pointer. Then you will stop and return. So a linked list is created. Malloc will tell the OS to give your program some memory, yes, and tell you the memory address. So free will block, yes. So loop. The loop will stop when I key in any invalid data. Okay. Maybe see whether it can work or not. But first of all, do you see that this one have some bug here? If anyone can find out any bug here? Pointer at what at first? temp at the beginning, it's not actually I can put it as a null pointer, or because I know that very soon here I definitely will assign it. So temporary is just it's just a, like what I said, I always need two pointer. One pointer always here, in here the head is always store the very first memory address. Temp is just help me to travel along this linked list. So this temp is not so important. So here I didn't assign anything at the beginning. You may not need to use it later or whatever. Is that the key is I cannot lose the first memory address. So the head pointer I need to make sure it work properly. The temp is just a temporary variable, temporary pointer to assist me to do some job. And here I would say that one of the key is I didn't free the memory in the end. I suppose good practice, I should free this particular linked list. Another problem is here I didn't cast it, but these two are minor in this particular example because I just run this program and then create a simple linked list, and then after that I will terminate the program. So it may not, if I forgot to free it, it may not create any big issue, but good practice is I should free it. And this one, if I forgot to cast it to the right data type, it may not have any issue. Normally the computer will do the casting for you, but again, it's a good programming practice is we should trying to cast it by our own properly. But there's no syntax error. The best thing to learn this thing is just simply write a program. So let's set discuss first. Back to here. I think for me, I would suggest you is not just read this thing. Maybe can I create a code block? The best way for me to learn any programming stuff is just write a simple program to test it out, see how it works. Just test. Linked list. Okay, same thing I show in the slide. Let me zoom a bit. Okay, this is the same code I use in the slide. Then I just simply compile it. Hopefully it works. Oh, okay, because I copy and paste this thing. Okay. Build. Then trying to run. Maybe I run, I cannot do any. You cannot see anything. Okay, I can key in 1, 2, 3, 4, 5. When I give A, then they will stop. Okay, this thing, because I didn't print anything, so you won't be able to see what happened actually at the back end. To do this, I probably have to use the debugger to help me to see what's going on in the memory. Then I will use the debug to declare. Okay, so when I'm in the debug mode, let me zoom in a bit. Same thing, I'm trying to type 1. Yeah, at the line 15, you can see that here. I hope you can see it. The head pointer is now at this moment. And temp is just some random number because I didn't assign anything at the beginning. So the temp is a random number. The I is the input given by the user. I type in 1, so I is 1. So at this moment, the computer have not do any memory allocation at line 15. I haven't executed the line 15. After I execute the line 15, I click this one, next line. They're executing the line 15. They will create a memory block to a new node for me. And the memory address of the new nodes will store in the head pointer. So the new nodes is create in C61 in the memory address C61700. So at this memory address, of course at this moment nothing inside. I haven't assigned any value there. So this, but you just think about it. This particular memory location is allocated for a list nodes. And this memory address is returned and assigned to the head pointer. So line 16, after I execute, you expect that the temp will be updated to 61700. So now, after the line 15 and 16, there's a memory nodes. There's a dynamic memory allocation allocate for this particular list nodes, the very first nodes. And head and temp, these two pointer store this memory address. And then at the line 22, at this line 22, I'm trying to assign 1 to this particular nodes, the item member. 1 will be assigned to the item member. So after this line, I expect that somewhere here, there's a 1 will appear. After this line 22, after I execute line 22, you can see here, I hope you can see it. If not, you can go and try by your own. Yeah, actually 1 is here. I think I won't be able to increase the size. Can I increase? Yeah, I can't. Yeah, here you can, I hope you can see it. There's the 1 is assigned to this particular location. Then this loop will repeatedly ask the user to key in the new text. So next I'm going to give to execute. Then I need to assign, let's say I assign maybe bigger number, maybe 15. Enter. So next, because head is no longer a null pointer, so you expect that you will execute this portion. So you'll come to here. So now I will no longer, you can find that in this part onward, I'm going to create the second nodes, third nodes, fourth nodes, and subsequent nodes. And I will no longer touch my head pointer because I need to keep the very first address. I cannot lose this particular memory address, C61700. So I will use the temp pointer to move along this new nodes. So here, after this one, you expect that you will assign the new memory address. They will allocate a new memory block for the new nodes and store in the link. So from that, the link should be somewhere here. Let's see how they create my next line. After this, yeah, the temp will be stored at, no, temp is not updated yet. The temp next is there. You can see the temp next. You can see what it is. Yeah, it's at the 61740, which is somewhere here. You can see head also is not surprising. Doesn't exist. Oh. Next. Temp next and head next are the same thing at this point. Yeah, 61740. So after this, I run this one. Then the next, yeah, after the line 20, the temp becomes C61740. Head still remain as a C61700. So that means the temp will move to the next nodes. Then of course you can see that after this the temp next become a rubbish because at this point I have not assigned anything to the temp next, which is the link of the second nodes. It's not assigned anything. And the temp item at this point is contain nothing. The head item is 1. And the head next item, which is the second node's item, will be same as temp item. Yeah. After this line 22, this temp item or head next item will contain the new data, which I key in just now is 15. So you expect that 15 will be assigned to it. 15. You can see it's stored in the 7-4 somewhere here. 0F in the hexadecimal. So this is actually 15. So this is, I will keep doing this every iteration to create a new nodes and let the temp to travel along this new linked list. And head pointer will remain at the first nodes, will point to the first nodes to remember where is the first nodes. When I reach the last nodes, maybe I can stop this program. I just create 3 nodes. Let me continue. Then I trying to stop this program. I just type in an invalid input, let's say A, to stop this while loop. Then you will directly jump to line 24. Then line 24 will just let the temp next become a null pointer. So right now the temp next is assigned to some random number. After line 24, they will assign a null pointer to it. So that will create a complete linked list. So complete linked list, you can use the head pointer to travel along to get the information of the first address of the nodes. So that's why I always need to have 2 pointers. The head always store the first nodes, the memory address of the first node. And then I rely on the temp to help me to travel along. Yeah, point to to store the memory address of the each nodes I would like to visit and move along with it. And at this point of time, you will find that actually the linked list still there. Well, it won't create any issue because in this particular simple example, I only create a linked list. I didn't do anything further. So at the time I terminate the program, although I didn't free it, but of course I wouldn't create any issue. But when you create a bigger and more complicated program, yeah, it's a good practice that when you no longer need it, but this particular memory block or this particular linked list, you should free it first before you move on. Otherwise, you may very soon run out of memory. Yeah, another problem, yeah, I think you can see that just now, I didn't, by good practice is you should cast it as a pointer because malloc, can I see? Maybe I have to stop it. Yes. If you're trying to do some malloc, can I show you the malloc? Let me see whether I can show you the definition. Yeah, cannot. Okay, here cannot show you the thing. As I mentioned in the last lecture, malloc is return the void pointer. But on your right hand side, this is the list nodes pointer. Malloc return a void pointer to ensure your left hand side and right hand side have the same data type. So I should cast it to a list node pointer. Although here they didn't give you any syntax error, but a good programming practice, you should declare a pointer. You should cast it as the right pointer. Okay, so that is how to create a linked list. So far, any question? What does the that's the next method? Yes. Then free head of free. You just need to free. Okay. If I try to free, let me try again. All these things you want to learn, you don't have to ask anyone. You can try to free head, see what's going on. Will it create any problem? Maybe I just put a breakpoint here. Okay, so now I'm trying to make my life simple. I just create two nodes quickly. 15A terminate. At this point, you will find where is my... Yeah, you can see every time I run the program, the memory address may not be the same. Just now it's a C610700. Now, my computer assigned 181700 to me. So this particular location store 1. And then my F is stored at somewhere here, I guess. 740. When I free head, what will happen? So this particular memory location is free. If you're trying to free them, not surprising, they will free. If you free the them, you will free the second nodes. Let me try again. Here I create two nodes. So now again, the memory, yeah, that's the malloc. Every time you execute the program, the memory address may not be the same. Now become 151700. It depends on your computer to decide the free memory, which allow you to allocate for this block. So after this line, the first memory block is free. You can see that 157400 still contain the 15 here. So after that, you will free also. You will free the 10 as well. Then just continue, then the program finish. So do we have to while loop to free? Yes. So the principle is quite simple. You malloc how many times? That means implied that you need to free the corresponding number of nodes in the end when you no longer need that particular memory block. In the example I showed you earlier, actually I create two nodes. One node to store the 1. The second node store the 15. That means I call the malloc 2 times. Implied that in the end, if I want to deallocate the memory address, I need to do it 2 times to free the memory block 2 times. Okay, so I may run out of times. Okay, never mind. I think I still got Friday. So maybe today I just show you how to declare this memory. I think it's very important. This concept, how to declare a basic nodes, and then how to insert the nodes and how to free the nodes. In short, you need to every time you need to declare, you need to create a nodes. You use the malloc to declare, and it can be your data member can be integer, can be anything. You will just assign it accordingly. After that, and then second thing you need to learn from this particular example is you always need a pointer to remember the very first memory address, the memory address of the first nodes. Because if you lost the memory address of the first nodes, it simply implied that you wouldn't be able to access the whole linked list later. So you need to make sure you won't lose the first memory address. And then usually we will declare another pointer to assist us that is the temporary pointer here, the role he play, to assist us to visit every nodes we are interested. Sometimes I may create more, depend the problem, depend the problem I encounter. Maybe later you see when I do the insert notes in the latter slide, yeah, you will find that I need to sometimes I may need to declare another one to help us. Yeah, because when I insert or remove the nodes, I not only need to know where is the current nodes, I also need to know where is the previous nodes, so that I can easily adjust the data structure of this linked list. So maybe I stop here. Yeah, today I think on Friday, yeah, this week anyway, this week I will talk about the linked list. So on Friday lecture, I will talk more details. I think this is another important concept you need to learn in this week. After you have the data structure, any data structure, typically you always should ask yourself is like what kind of a utility function or interface function you need to assist you to visit, to access the data in this particular data structure. Like this example is a linked list. Probably a few things you need to do. Print the list, output all the data in the data structure. So here I will show you the print list. And then of course, you have a data in a data structure. You need to do some searching. You need to find the nodes. You need to find certain nodes, whether it's inside the data structure or not. Or you want to visit particular data in this linked list. Then the third thing and the fourth thing, you can visit, you can print out. Of course, you also would like to insert the new data or remove some data from the linked list. And the last one is trying to check the size to know how many nodes are there in this linked list. So these are some utility function you need to help you to solve the problem or you to use the linked list to solve the problem. These are some utility function. Maybe before I end today's lecture, I can quickly show you how to print. I think print the list after what you have done earlier just now, you create a linked list. If you want to print out all the items in the linked list, yeah, I need to know where is the first address. Where is the address of the first nodes? So it's just, so I need to, you just need to give me, in this print list, I expect that you need to tell me the head pointer. You just need to give me the first address. It's good enough. So you expect that this print list function, you need a pointer. And this pointer contains the memory address of the first item you want to print out, which is the head pointer in this example. So they contain probably, if in this example here, that's when I need to pass 0x1000 to you, which store the memory address of the first nodes. Then to do this again is the same thing. You just need to run a while loop. Every iteration, you just print the item, and then you will move to the next nodes through the link. From the link, I will find out where is the next nodes. Then the second nodes, I will print it out. Every iteration, then I will base on the link to find out the next nodes again and again and again. So when I run this program, in the first iteration, I will print out 20. After I print out the 20, my current pointer will move to the next nodes. Yeah, which is 1040, which I can obtain from the link in the first nodes. Then I will be able, in the next iteration, since the current pointer is not a null pointer, there's a valid memory address here. So I will be able to print out the second item, the value, which is 30. Then I will update my current pointer to the next location, which is 1080. Then in the third iteration, I will print out 60. Then the last one, I will print out 70. After I print out the 70, my current pointer will be updated to a null pointer. Then in that circumsystem, I will end my while loop because I already, and you can see that from the output, I already successfully print out all the nodes, all the item in each node. Yep, that is the print list to print out all the input. Of course, this depends the data. Here is a simple, in this example is I only have one member. But sometimes you may have more than one member. Sometimes maybe it contains some string, can be anything. Depend your application, depend on your data structure. So you will do different printf here. But the basic idea is always you use one pointer to update it. After you print out all the item, you just update it and then move to the next location, Okay, so that is today's lecture. Friday, I will cover the search, insert, and delete and sites. I think the hardest one should be delete. I will not talk too details. That will left for you to practice during the lab section. I only focus on the insert nodes on Friday. Yeah, I think that one is the most difficult one, which maybe I can quickly, the finals. If this slide already uploaded, the thing I would like to highlight is in the insert nodes. On Friday, I will talk more details. It's going to use a double pointer. It's a pointer to a pointer. And why do I need a pointer to a pointer in the insert nodes? I will cover on Friday. You will find that other function, I don't need it. I just need a single pointer. I just need a pointer. In the today lecture, I show you the print. The print also just single pointer. Only the insert nodes need pointer to a pointer. That will cover on Friday lecture. That is another important concept you need to know for a linked list or this module. Okay. I will release the lab and the tutorial today or tomorrow. I need to revise the content. So so there's something I need to change it. So yes, so-called the double pointer or pointer to a pointer. We'll cover on Friday. That is the important concept you need to know on Friday. Okay. Any other question for today's lecture? You can do that. How do you free the entire? So one thing you just need to remember when you declare you malloc and free is a complement. One is allocate the memory block. The other one, free, is the function to deallocate the memory block. So the principle is quite simple. You just remember that you declare the malloc how many times. You need to reverse deallocate the memory block. You need to do it the same number as how many times you malloc it. That's when you need to call the free function how many times. It should be same number. Like I use the malloc 2 times. I do the memory allocation, create 2 list nodes. Imply that when I free, I need to free it 2 times. And normally I need to free it in the reverse order. Forward also can. I think, yeah, for the linked list is okay. Let's say before you free it, if you look at it, when you free it, before you free it, you need to know where is the next node. So always I need to update my head. I need two. So probably I need two pointer. Before I free the first nodes, I need to have a pointer point to the next nodes first before I free the first nodes. Because once I free the first node, I will lose the link to the next nodes. So in that circumstance, you expect that in here I need to write a while loop, and every time I will check whether the next is null pointer or not, and then I will update a pointer to the next nodes first, and then followed by free the current nodes. Okay, the current would be a new variable declared when making the structure. Is it? The pointer, I can declare a lot of pointer. I think if you're talking about in this, here is just another pointer. Yes, you can have hundreds of a pointer point to the same location. I can declare a lot of pointer point to the same memory location. It's okay. It can be temp. In the main function, I call it temp. In the function, in another function, I can give any name. When you, okay, that is later we will explain why you need a pointer to a pointer. When I call this, that's when in the main function, when I call the print list, I only pass the pointer value to this current pointer. That's when this current pointer just contain the memory address, which is like in this example 0x1000. In the main function, there's another guy called temp, which also contain the memory address 0x1000. So that means you have two pointer, one pointer in the main function point to this memory location. And then I have another pointer called current pointer in this print list function, also point to the same memory location. Yeah, which can let you print out all the data in the linked list. So the name is not so important. And you can declare any number of pointer to point to the same memory location. It just contains the memory address. Free inside the same while loop that we used to. Normally we wouldn't do that. We will free the memory block is when you no longer need that data structure. So after I declare, maybe I need to do something first before I free it. You in practice definitely you will not malloc it and immediately free it. Then what's the point you allocate it? You definitely create the data structure first and then solve your problem. After you solve your problem, you no longer need the data. You would like to free the memory block, then you will call the free function to deallocate the memory block so that you can let other to use it. Okay? If you have other problem, you can drop me an email. So that is today's lecture. Thank you and goodbye.